This is AQA GCSE Chemistry. It is the Trilogy Foundation Paper 2 from 2018. And this is question 5. The whole of the question is laid out for you to try first before we review. So here is 5.1. You can pause as you go. 5.2 and 5.3. 5.4 and 5.5. 5.6. 5.7, and now we're going to take a look at the answers. So, a student investigated the effect of the size of marble chips on the rate of reaction between marble chips and hydrochloric acid. 10 grams of marble chips in the flask, 50 centimetre cubed of HCl added, and a timer started. The mass lost was recorded every 10 seconds, and that was then repeated with different sizes of marble chips. So what is the independent variable? Well, the independent variable is the thing that you change, that you're choosing to change. And as it says at the bottom, we're doing this with different sizes of marble chips. So a control variable is something that is kept the same. Now, the mass lost from a flask will not be the same. That is actually the dependent variable. The size of the flask will have no impact, and the time taken isn't a control variable because the time varies. Or we're doing every 10 seconds, but we're seeing different masses after those 10 seconds. So the thing that we are keeping the same, and it's there in the method, is that we are using 50 cm cubed of HCl each time. So the volume of acid. 5.2, the equation for the reaction is provided and we need to name the 3 compounds. Going to start with perhaps the most complicated one, and that is CaCl2. Now we know it's got calcium, we know it's got chlorine. Hopefully you're recognising metal and non-metal. It's ionic. We're making a salt. And the salt here is calcium chloride. H2O, water, CO2, carbon dioxide. Another student suggests putting some cotton wool in the top of the flask. Why would this improve the investigation? And what we're looking for here is that we're going to prevent loss of acid. Now, it's important that we think about that being splashes of acid that could be lost otherwise. It's not going to prevent evaporation because vapour can pass through cotton wool. On to 5.4. The reaction produces 1.6 grams of gas in 30 seconds. Calculate the mean rate of reaction using the equation provided. So, mass is 1.6, time is 30, 1.6 over 30 gives a value of 0.0453. But we need the units as well. So, for the units, substitute those in. We've got grams and we've got seconds. Grams divided by seconds. So the unit is grams per second. And on to 5.6, where you're plotting a line of best fit. Difficult for you to do on screen, I acknowledge. But I've plotted those in, and what you can hopefully spot here is there is one of them that we're not going to use in the line of best fit. You can recognise that there is an anomaly, something that doesn't fit the pattern. Once that's gone, we actually get the scope to do a very nice curve of best fit in the remainder. And on to 5.7, we've got here a large marble chip, 8 small marble chips. The large marble chip has the same volume as 8 small marble chips, but a different surface area. Why do the 8 small marble chips react faster than the large marble chip? Well, in part it's because they have a larger surface area. We've added exposed surface that can then collide with other reactants and react. So increasing surface area increases rate of reaction. We're now down to 50-50. As I've just said, that means that there can be more frequent collisions. So the correct answer is the second one down here. And that takes us to the end of the question.